Hey guys, welcome back to the shop. We once again have the Mopar water pump housing in the shop here to work on, and it's not because of the previous machining we did here on these faces. In fact, that turned out great. He started assembling this motor over the weekend and had that bolted on. He even showed me a picture of his laser alignment with the pulleys and said that it was just absolutely perfect alignment there. But they ran into another issue, and what he needs done is this water neck right here modified for the thermostat. So they're going to be running this adjustable water neck right here that's got an O-ring that seals, that bolts on there and seals. But what he's going to need is a slight counterbore for the thermostat to sit in, so that this will sit down in there and hold it and be, you know, just about flush with the top of the face right there. So he gave me a dimension of 51 thousandths. Now this is not the thermostat that he's going to be using. I think he said this is one that they use just for mock-up work. They've actually kind of sanded on the outside to bring that OD down, but this was just the example that he brought me. So this is not going in there. In fact, when we go to do the counterbore, this will not fit in there because the one that he has, he says measures 2.240 inches on the OD. So he wants that OD machined, or that diameter counterbore machine, and we're going to go about 50 thousandths deep, so that'll kind of sit flush. And then whenever the bolt-on water neck goes on there, that O-ring seal should fit down in there and be pulled down to seal just like it's supposed to. All right, so that's what they're asking for, and that's what we're going to do. So we're going to set this up in our KBC mill again. We'll use these faces here. I'm just going to set up 2 angle plates, and what we'll do is kind of go through here like this with a couple of bolts, one on that side, and we can go one on that side right there, and just bolt it to a couple of angle plates, and then get this nice and level and indicated, centered up on there, and we'll just do a little counterbore. So for that op, what we will use, I have the Criterion boring head, and we'll use a boring bar like this right here and the Criterion to make our counterbore inside that water neck. All right, so I'm going to go start setting this up in the mill, and I'll bring you along for the ride. We're getting our angle plate set up here on the mill. We've already got these where they need to be, bolted down. And something that I wanted to point out that we went ahead and did off camera is inside the water neck housing area here where we got to bore it, I went ahead and polished that just slightly. On this side here and on that side, that's where the parting line is when they cast it. It was pretty rough in there. There was some areas that were protruding off the wall. So I just took a flap wheel and just buffed the inside of that just to kind of get rid of that roughness down in there, because we need to get in here and indicate this and find the middle of it. So got that taken care of. All right, and we got our setup here ready to go. So I had to get this mounted so that the water pump housing would hang off the table, because this area here where the hose connects, if I was trying to use these same angle plates, it would be up too high and I wouldn't be able to bolt them into these slots. So we've got it hanging off the front, so it'll be bolted on just like that right there. And then we'll be able to indicate this and get this trimmed in nice and flat. Just getting it lined up the way I had mocked it up. Going right through the slot with the 3/8 bolts. There we go. Using a heavy duty 1/2-inch washer on the back, and then a standard 3/8 washer, and then just a regular hex nut. About like that. See if we can get this snugged up where we can bump it around. About like that right there, okay? So this flange, we need to make sure it's nice and flat, and then we'll find the center of it. We're just gonna rough it in with this little bench level right here. There's a little stair indicator. Love this guy. Perfect for little mill setups like this. So not too bad. And by the way, the mill isn't really leveled properly anyway, so this is probably gonna be off. This will get us close though, so we're gonna see if we can get it a little closer. That looks a lot closer there. we'll put an indicator on there and go ahead and start sweeping that flange. We've got a Starrett 196 back plunge indicator mounted in the spindle. We're going to use this to sweep across the face and get it bumped level. So we'll check this way first, side to side. See how far are we out on a level in our X dimension. So 0. I saw it going up. Okay, so it's about 5 thousandths high on this side. Simple enough to fix that. I do want to go across in the Y direction. And see where it's at in that direction as well. All right, that's still a couple thousandths off. Let's go ahead and check this way here, because I don't know if they've got it machined perfectly square to the back. So that looks like 5 thousandths plus. Where are we at over here? Yeah, that side's low. So it's kind of kicked at an angle in that direction there. I think that's quite a bit. So that's about 10, 12 thousandths difference right there. Let me go ahead. I'm going to cut some shim stock. Well, maybe we'll go with some 10,000 shim stock. I'll put it in here and see if we can push this back. Just get it a little bit closer. It doesn't need to be 0 sweeping all the way across there, but let's get it a lot closer than what we have right now. Okay. Got some 10,000 shim stock that I cut. Got this side loose. Oh yeah, so I can just pull that out like that. We'll slide this down in here behind it. We'll see if that's going to help us there. Now we'll do the same on this side. Not cooperating very well with me. It's already pulled off. Now, of course, that probably changed side to side, so I'm going to have to check that again and move it, I'm sure. That's better. So we'll go back side to side. Let's see where we at there. Closer than I thought. That's pretty close. That's within 1 thousandths, I believe. So let's go to the middle. Let's check this way again and see if we're still going downhill. All right, so 0. 4 thousandths. All right. Tell you what, I'm going to do it again. I'm going to bring you guys back when we're ready to sweep it. I think I'll go ahead and cut some 15 thou shim and see if we can get that closer. All right, 15 thou shim stock in there now. Looks like we might have gotten a little closer that time. Oh yeah, okay. Now that's within 1,000, so we're gonna call that good. I just gotta go back and get our X dimension back where it was, where it needs to be. That's minus a half. Oh, -1. You know, that's pretty good. Might as well not even mess with it, but you know me, right? Let's see if we can move that just a skosh. Zero. All right, 0. There we go. Okay, we got it level now. Go ahead and make sure that our bolts are tight. That should be good there. All right, now we got to find the center. So to find the center, we're going to go a little different route than what we typically do. Usually you see me set up a test indicator inside here, or even a coaxial indicator, which works really good. But since this is not going to be a perfectly round hole right there that we want to find the middle of, just thought I would go a slightly different route. We're going to be using my Heimer 3D sensor here to find the center of that. The way this works right here, in case you haven't seen it before, and I've showed this over on the Flex quite a bit to find our work offsets, is, make sure you guys can see this okay. If you guys haven't used this before, it works pretty good. You just you put this in the spindle and position it so that you line up the tip on 0, 0. So notice you have a dial down here with a 0, and then of course you have that one on the dial there as well. So you just line up, and once you line up 0, 0, that's the edge, and then you can go the other direction with it as well. So it's made to go in any direction, including in. So you can push in on it to find the top of your work surface there as well, as long as you know what the length of your gauge length there is. So we're going to use this to find the center. Let's see if we can, actually I'm going to have to bring that down so I can get it in. I just moved it off out of the way. Try to minimize my hand cranking up and down on the knee on this thing. I've actually got a power feed unit that I bought from KBC a while back to mount on here for our Z up and down, and I just haven't got it mounted yet. I've been wanting to get to it, and we're going to get to it soon, I hope. So there it is, mounted in a 3/4 inch collet, and we're just going to kind of come and I'm just going to kind of eyeball the center of it, get it kind of close to the center of that hole there, and I think that's going to work. So we'll go in our Y direction first, find the center, and then we'll go in the X dimension. I'll get you in closer so you can see this. All right, I think you guys can see that. What we're going to do is bring that ball tip just down below the surface there, somewhere about there, lock the quill. All right, I'm going to bring the table to me, and you see the needle. That's 50 thousandths away, and we just bring this up gently, line it up on 0 there. Okay, so you got a 0 up top, 0 down below. So the edge of that hole is directly in the center of this gauge here. Now we're going to reach up on our DRO. This is from the last job. We don't need that. We're going to go ahead and come up here to our DRO. We're going to 0 out our Y. Now let's go back to our gauge. All right, we're going to bring it back across. Do the exact same thing. 0, 0. All right, let's go back to our DRO. So on the DRO, we're going to use our half command. Most DROs have this, so you just push your half, and you want to push the axis that you want to 0. So we're going to hit Y, and there you go. So we're just going to bring this to 0. Hopefully you guys can see that. So that's the center in Y right there. So now we're going to do the same thing in our X dimension. All right, same thing in X. Now this is why I polished that inside, to get rid of that roughness of the parting lines. That looks pretty good. All right, I'm going to reach up here. I'm going to 0 out X. Now let's go the other way. I got a handle that's unscrewing over here. One sec. All right, let's go the other way and do the same thing. All right, 0, 0. Going to reach up. I'm going to hit half on the DRO, and then hit our X. That's going to split it in half. Now we're going to bring our DRO back to the center and line up on 0. All right, it's a half a thousandths off either way. That should be the center of our hole right there. And you can see how the Heimer 3D sensor works pretty good doing stuff like that. As I said, we're about a half a thou off on our DRO. So first time I actually used it over here on the mill, I thought this would be a great job to use that for. Very versatile indicator. I'd recommend having one if you can put one in your toolbox. Okay, I think we're ready to go ahead and start using our boring head here. And I'm going to point out, so this is the tool we're going to use. This is the boring bar. This is M42 Cobalt. This is a set that I got, different links that go with the criterion here. So this is a perfect boring bar for an application like this. But I wanted to point out that all of your boring bars, typically are ground just like a lathe tool, any kind of tool that you use in a lathe. You're going to have back relief here. All right, so the way this came, if I was to come down and bore it, you know, take a couple steps, you're going to see a couple little steps in the bottom of that face. We don't have the ability to face across like you would in a lathe or a different type of boring head that's used for boring and facing. So what I did is I went to the pedestal grinder and removed that relief on the bottom there, got it at very, very, very close so that we have nearly a flat bottom when we come in here and mill that. Now it's not going to look bad because we're really only taking like 100 thousandths out of that. So you're only going to see about 50 thousandths per side once we get down there. So I don't even think you're going to see any kind of step with that very slight amount of out of squareness that I have on the end of that bar. But just want to point that out. We're trying to make as flat bottom as we can. So we'll go ahead and get this guy installed. I want to use that most outside hole right there. And we'll get this locked in. I usually just, let me turn it so you guys can see it here too. I just kind of look straight through the center line and try to get the edge of that cutter or boring bar just kind of in line like that. Looks pretty good, so we'll go ahead and lock that in. All right, and then the next step is that we need to come down here. So that's actually a little bit too big there. So what I'm hoping we can do is back it out. Let's see if it'll back out enough. Oh yeah, okay. See if it'll back out enough. Yep. All right, so now what we can do is just start going around like this until we touch the inside wall, and that'll be our start point right there. So we just go around it. Gotta remember which way is positive. Just keep rotating around. I usually kind of get it close to the wall like that and just rotate it and wait for it to touch. All right, there you go. It's touching there. Yep. So we're touching on this side right here. So we're going to call that our starting point. And that should be around, when I measured it was somewhere around 2 inch, 130 thousandths or so. So like I said, we've got about 100 thousandths. So that's lined up on the 10. We'll go ahead and offset it and get our first cut established. So this boring head says 1 division, so each line is 1/1000th of an inch. So I hope that's what it is. I do have a boring bar, or I'm sorry, boring head that takes double that. So every line is 2,000 instead of 1. So let's hope this is off the diameter. We're on 10, so let's go ahead and go 50 thousandths. That'll be, get it where we can see that. So that's 10, 20, 30, 40, and 50 right there on the 60. And then we take and go ahead and lock the side here. This is, so you got a gib in there and a set screw pushes against that to keep this from moving. All right, don't take much, just snug it up. That should be good. And what I would like to do is I want to lock the spindle. In fact, we're just going to go ahead and bring this up all the way like that. And I'm going to go ahead and run the whole knee all the way up to kind of maximize the rigidity of our setup here. I want just enough that we have a little clearance. We'll just go all the way up with it like that. How about that? Yep. So I can tell that we're going to be cutting a slight amount there. So I think the next step, we'll just go ahead and turn our board head on and we'll bring the knee up until we start touching. That's going to be our 0 point. We're going to go, he said 51 thousandths, so we're shooting somewhere around the 50 to, I'm going to say 50 to 54 thousandths depth. Let's go ahead and get it touched off, set our 0 on our knee. We're going to be going reverse direction, low gear. I'm just running slow because there's not much going on here, not much material, so I don't need to run this thing super fast. Slow and steady. That's what we're looking for here. There's our touch. All right. and it's looking good. It's touching all the way around that. So we've got it nice and trammed in, nice and level there. So now we'll go ahead and set our 0 on our knee right here. And I'm going to be using this to bring it up. So we're ready to go. I'm going to go ahead and turn it back on. I'm just going to bring the knee up nice and slow and controlled to about 50 thousandths. That's 30 thou. 40. There's 50 thousandths right there. So I want to do some measuring there. We've got our knee dropped down 50 thousandths below our 0. So the easiest way to do this is to move the table over here so I can get in here and measure it. So we're good. We're not going to hit our bar. And since we have our DRO set to a 0, we can go right back to that position. Just want to get it out here so we can measure it. I think one of the easiest way to do it is just to measure this using some calipers here. And we're going to see how close we can get it. Look at that, just about 2 3/16. I saw a 187 on there, so we're gonna consider that our dimension that we just measured. So we want to take that to 2.240. Just did the math on the calculator. That should be about 53 thousandths to get us our diameter there. I left that last cut just slightly small with the hopes that we just had a little cleanup to make here. I also want to clean the bottom up there as well because I've only gone down 50 thousandths. So let's see if we can get a good reading here. Reading that stuff upside down, it's a little tricky. And I'm trying to make sure that I'm off the radius. Got a little radius honed on the bottom. So I think I'm getting 233. I'm just gonna keep checking this and seeing what we got. There we go. 35, I got 235 that time. $235.5. Looks like 235.5. There we go. Let's see if we can lock that where it needs to be. 235.5. So we got like 5-6 thousandths that we need to come out of that. So we're going to reset that, make one more cut. I'm going to clean the bottom up at the same time, and that should be where it needs to be. So let's take 6 thousandths for our final cut. That should have been our final cut there. Let's go ahead and get a measurement on it. So I brought the knee up a total of 52 thousandths, and I can tell that that cleaned up the bottom. It looks nice down in there. And then we should be maybe about 1 thousandths over our target bore. Let's see what we can measure here. It was at 241. 242. All right. So I think we got 241 to 242. So that's going to be, 1/2 thousandths over our target, which is going to be fine. He says that that's what that thermostat measures with his calipers is 2.240. So if that's the case and it's round, it should just fit down inside that lip right there. So that should be exactly what they want. So I think besides a little bit of cleanup and getting it out of here, this machining part of it is finished. All right, we'll do our little mock-up here so you guys can see what we're talking about. So a reminder that this thermostat is not the one going in there, and it's actually been ground down to about the proper size. So I'm not sure why he didn't bring the actual thermostat, but he measured it with his calipers saying it was 2.240. So if that's the case, it should fit down inside this little counterbore. But it's going to be like this, though. We can stick it one side down in there like that. You can see this is not going to fit because it's not round. But if you do one side, it should go down there and just kind of sit flush, like so. And then this water nut here is going to be bolted down on top of that. And then that should allow the O-ring to come down here to this face of the flange and properly seal everything. Or so that's what I'm told, but it looks like that should be what they want. So I think the only thing left to do is just get it out of the mill. I did measure it a couple more times off camera, and I landed on 2.243 inches for our final dimension there. I think that's going to be good. That should give him, hopefully if he measured it accurately, that should give him a couple thousandths clearance so the thermostat actually, sit down in there without being too tight. We're just taking our bar out of here, getting that out of the way. So hopefully everything's going to be good and he can come and get it and put that thing back together. And I'm kind of hoping that no news is good news. I realized I didn't show you guys measuring the depth there. So we've got our stare at depth mic. We'll put you, let me see if I can get you in here nice and tight so you guys can see this. Right up to that edge. And right there. It's actually too much with the friction thimble. It moves. I think it moves. Right there, I'm getting 52 thousandths, which is exactly what we brought it up there. Let's do this again so you guys can see it a little bit closer. Lock it, don't move. So just at 52 thousandths on our depth there. Beautiful. Okay guys, well that's another job done. This one is complete. I can go ahead and call the customer and let him know he can come pick this up. This was sort of like one of those hurry things because whenever he picked it up after the last modification we did here, that was on a Friday, which worked out perfect because he said he wanted to work over the weekend on getting this 440 back together for that. It's a 72 Dodge Charger that he's restoring, that this is going in. And he was wanting to get this engine back together over the weekend. And he had called me on Saturday and said, oh man, we've got another issue here that we didn't foresee coming. So he called and asked, is there any possible way you can get this done Monday? And I said, yep, we can handle that. I knew exactly what we needed to do. The setup that you guys saw with the angle plates, the bore head, everything was exactly as I envisioned that I was going to do this job on Saturday when he called me. And I thought it would be another good job here to show on the channel on how we can set up a workpiece like that, utilizing all of our machine tool accessories to do our work holding, our measurement tools, our criterion boring head to get our counterbore done. Everything worked out really good there. So I hope you guys enjoyed this video as always, and I hope to see you back here for the next project. Okay, we'll see you then. We're back on the Mopar water pump housing once again, but we're hoping that third time's a charm. I went ahead and counterbored this guy one more time. We just got it to size. So they got their thermostat in that they were wanting to use. They decided to go with this one here. I believe this is a high flow thermostat, and it's got this rubber seal in there. It's like a square O-ring that seals the flange. So this is an off-the-shelf part that you can get. They ordered this from Summit Racing. This should be able to be replaced if needed. Instead of having a custom size hole, this is a standard item that they can replace themselves. So we got it counterbored. It's got a nice close fit on there where you can actually just kind of push it down in there like that. And I left it so that it's approximately 15 thousandths proud there to help push down and seal, just like that. And then they have this adjustable water neck that's going to be bolted down on top of it, just like that there. So hopefully this is gonna, you got an O-ring that goes there on the adjustable water neck. It should seal there as well. So hopefully this is what they're looking for and what's gonna work for them for this 440 that they've been building. This has got a nice fit in there. I just have to pull it out like that. So hopefully that'll give them a nice seal, and this is what they want, and they can go ahead and get this motor put back together now.